Welcome to Metra VC120 video training. In this video we'll demonstrate how simple it is to calibrate a sensor with VC120. The VC120 calibration system is designed for calibrating various types of vibration sensors. In spite of its compact housing, VC120 is transportable, battery-powered and offers a wide variety of functions, which are otherwise only known to stationary, significantly more cost-intensive systems. It produces sine wave vibrations in the range of 70 to 10,000 Hz at a constant amplitude of 1 meter per second squared RMS. The test object can weigh up to a maximum of 400 grams. This means that you can calibrate lighter sensors as well as heavier industrial types, or high sensitivity sensors. The instrument has an M5 screw thread for attaching the sensor. Additionally, a selection of thread adapters are included as standard accessories. Calibration is done at fixed frequencies which can be selected with the shuttle wheel. The VC120 can also record frequency response and sweep. At the back of the instrument you'll find a connection socket for the sensor signal. Compatible sensor types include piezo sensors with charge output, IEPE sensors and voltage signals. Here you'll also find a USB port for PC-controlled operation and a socket for using external power supply, which is also used for charging the built-in accumulator. The measured sensor sensitivity is shown on the LCD display at the front of the instrument. All other controls are located at the front of the instrument, including an LED indicating battery operation. The instrument is simple and intuitive to operate using the 3 buttons and shuttle wheel. Now we'll demonstrate how to calibrate an accelerometer without connecting to a PC. First, screw the sensor onto the vibration shaker using a stud bolt or thread adapter. The coupling surface of the sensor should be lubricated with silicone grease to improve transmission. The sensor needs to be screwed on tightly, however the torque should not exceed 5 Newton meters. Small sensors often don't have a mounting thread. In this case you can use adhesive wax or cyanacrylate. Alternatively, to safeguard the shaker head, use a Metra Type 29 adhesive pad. Connect up the sensor to the BNC input socket at the back of the instrument housing. Switch the instrument on by pressing the red button. Press F2 to go to the menu. By turning the shuttle wheel and pressing F2 again, you can move across to the left menu item for selecting the input type. To select the input type, turn the shuttle wheel. You can choose from the following options: Q for charge, U for voltage, or ICP for IEPE. We want to calibrate an IEPE sensor and press F1 to confirm our choice. By turning the shuttle wheel, you can adjust the frequency from between 70 and 10,000 Hz. The measured sensitivity appears on the display. By pressing F1 you can switch from a coarse to a finer frequency step at intervals of 1 Hz. A more convenient way to operate VC120 than via the front panel is by using the calibration database. With the calibration software, you can also carry out frequency sweep measurements. The software offers the basic functions of modern calibration technology, including a customer database, sensor database, and complete archiving for all recorded data. The VC1XX calibration database software, including the instrument driver, can be downloaded from our website. Connect the VC120 to your computer with the mini USB cable and switch it on. When connecting up for the first time, you'll be asked to install the instrument driver. Now start the calibration database software. The instrument will appear on the display with its serial number. When using the software for the first time, you'll need to enter the license code, which you received with your instrument. After entering the code, you'll have access to all program functions. At the top left, you'll see the control panel for manually operating the instrument. The display format is similar to the instruments. By clicking on or moving the slider, you can set the vibration frequency. Furthermore, you can edit input type, calibration parameters, and other parameters. Click on Start Acquisition to start a manual calibration. The recorded sensitivity will appear on the screen. By pressing Start Sweep, you can record a frequency response graph. You can edit parameters such as start and stop frequency or frequency increment. Click on the diagram to select axis scaling or export options. Database-supported calibration is by far the more practical of the two options. Calibration is carried out automatically in accordance with saved templates. Results are assigned to customers and stored in the database. The database hierarchy is reflected in the selection tree at the bottom left. Below your VC120, you'll see the selection menu for customers, sensor types and sensors. Under Customers, you can enter the contact details of the client commissioning the calibration. Sensor types is used for entering and selecting typical parameters of the sensor to be calibrated. Here you can specify the type description, the manufacturer, sensor output type, weight, mounting method, the unit of measurement to be used, transducer electronic datasheet, and so on. You can also enter one or two reference frequencies to which the sensors should be calibrated. Entering the permissible tolerance will enable you to check the plausibility. Before you start the calibration, you'll need to create or select a calibration template. To do this, click on Settings, Calibration Templates. The calibration template contains the settings to be applied on VC120, as previously introduced with the manual calibration. Once you have completed this last step, all preparations are finished and you can start with the calibration. Click on Calibration, then select a sensor type, enter the serial number, select the customer and then the template. Next, click on Add Calibrate. The steps saved in your calibration template will now be automatically executed. The measured values are compared with the permissible error margins from sensor types, and depending on the permissibility, they appear in green or red. As the last step, the frequency response graph is measured. Under Sensors, you can find all previously completed calibrations sorted according to type and serial number. Here you can compare the last calibration with previous calibrations and produce trend reports. When you've finished your measurements, you can create a calibration certificate. Select the relevant entry from Sensors, then the tab Details and click on Open. The protocol contains details of the calibration lab, a company logo, the measured values including frequency response, and selected typical coefficients. Thank you for your attention.